In the annals of aviation history, few achievements have captured the public imagination quite like supersonic flight. The ability to travel faster than the speed of sound once seemed like the stuff of science fiction, but became a reality in the mid-20th century. However, the dream of widespread commercial supersonic travel has remained elusive, largely due to one significant drawback: the sonic boom. The most famous attempt at commercial supersonic flight, the Concorde, offered the tantalizing prospect of crossing the Atlantic in just under 3 hours. Despite its technological marvel, the Concorde's reign was short-lived. Concerns over safety, cost, and environmental impact led to its retirement in 2003. But perhaps the most limiting factor was the Concorde's inability to fly over land due to the disruptive nature of its sonic boom. Sonic booms, the thunderous sounds created when an object travels faster than the speed of sound, have been a persistent obstacle in the development of supersonic commercial aviation. These booms are not merely a momentary inconvenience. They trail behind the aircraft for its entire supersonic journey, potentially causing disturbances and even physical damage to structures on the ground. As a result, many countries have implemented laws prohibiting non-military aircraft from breaking the sound barrier over land, severely limiting the potential routes for supersonic commercial flights. Enter NASA's QUEST program, which stands for Quieter Supersonic Travel. This ambitious initiative aims to overcome the sonic boom barrier and usher in a new era of supersonic commercial flight. At the heart of this program is the X-59, an experimental aircraft designed to achieve supersonic speeds with a dramatically reduced sonic boom, or as the engineers prefer to call it, a sonic thump. The X-59, developed in partnership with Lockheed Martin's Skunk Works division, represents a significant leap forward in aeronautical engineering. Its design is a testament to the principle that form follows function, with every aspect of its unusual appearance serving a specific purpose in mitigating the sonic boom. To understand the X-59's innovations, we must first grasp the physics behind sonic booms. As an aircraft moves through the air, it creates pressure waves. At subsonic speeds, these waves propagate ahead of the aircraft. However, when an aircraft exceeds the speed of sound, approximately 340 meters per second at sea level, it outruns these pressure waves. The result is a continuous buildup of pressure, forming shock waves that we perceive as a sonic boom. The key to reducing the intensity of this boom lies in manipulating how these pressure waves form and dissipate. The X-59's design aims to do just that, transforming the traditional N-wave pressure signature of a sonic boom into a smoother, less intense form. One of the most striking features of the X-59 is its extraordinarily long nose, measuring 11.5 meters. This elongated nose serves a crucial function. It allows the air molecules more time to move out of the aircraft's way, preventing a sudden buildup of pressure at the front of the plane. This gradual displacement of air is fundamental to softening the sonic boom. Another notable design element is the absence of a traditional cockpit window. Instead, the X-59 utilizes two small mounted cameras and a 4K live display system to provide pilots with a forward view. This unconventional approach allows for a smoother nose profile, further contributing to the reduction of the sonic boom. The bottom of the aircraft is remarkably flat, allowing for uninterrupted airflow. Most protrusions and necessary structures are positioned on the top of the aircraft, shielding the ground from any additional shock waves they might generate. These design choices reflect a meticulous approach to managing the aircraft's interaction with the air it passes through. The development of the X-59 has relied heavily on advanced computational modeling and wind tunnel testing. Three-dimensional modeling has played a crucial role, allowing engineers to digitally test and refine designs without the need for costly physical prototypes. This iterative process has been essential in optimizing the aircraft's shape for minimal sonic boom generation. Wind tunnel testing with scale models has provided valuable data on the actual formation and intensity of shock waves under various conditions. These tests have been instrumental in validating computer models and fine-tuning the aircraft's design. As the X-59 program moves closer to real-world testing, the team faces unique challenges. The very nature of their mission, to fly a supersonic aircraft over land, requires special approval from the Federal Aviation Administration. The test flights will need to adhere to strict guidelines, including flying only in designated areas and providing ample warning to communities in the flight path. These community-based tests are crucial to the X-59's development. They will allow researchers to gather real-world data on the impact of the sonic thump on populations below the flight path. Surveys and studies will help determine whether the reduced boom is indeed as unobtrusive as hoped, potentially paving the way for changes in regulations governing supersonic flight over land. The X-59 program is also leveraging cutting-edge technology in its evaluation process. Newly developed shock-wave photography techniques will allow researchers to visualize and study the aircraft's pressure waves in unprecedented detail. This visual data will be invaluable in correlating the aircraft's performance with its effects on the ground. While the promise of the X-59 is exciting, it's important to note that a quieter sonic boom is just one piece of the puzzle in making supersonic commercial flight viable. Other challenges, such as high operational costs and environmental concerns, particularly regarding carbon emissions, remain significant hurdles. However, if successful, the X-59 could open up new possibilities for air travel. The ability to fly supersonic routes over land could make high-speed travel between any 2 points on the globe a reality. This expanded route flexibility could potentially make supersonic flight more economically viable than previous attempts like the Concorde. The implications of successful quieter supersonic flight extend beyond just faster travel times. It could revolutionize global business, allowing for same-day return trips across continents. The tourism industry could see a significant boost, with distant destinations becoming more accessible. Moreover, the technologies developed for the X-59 could find applications in other areas of aviation and aerospace engineering. As we look to the future, the X-59 represents more than just an attempt to bring back supersonic passenger flight. It symbolizes humanity's ongoing quest to push the boundaries of what's possible, to innovate in the face of challenges, and to reimagine the way we connect across our planet. The journey from the thunderous sonic booms of early supersonic flight to the promised sonic thump of the X-59 is a testament to human ingenuity and perseverance. It reminds us that with creativity, advanced technology, and a willingness to challenge conventional wisdom, we can overcome seemingly insurmountable obstacles. As the X-59 progresses through its testing phases, aviation enthusiasts and the general public alike will be watching with keen interest. The success of this program could mark the beginning of a new chapter in the history of air travel, one where the sound barrier is no longer a limiting factor, but merely another milestone in our ongoing exploration of the skies. In conclusion, the X-59 and NASA's Quest program represent a bold step towards realizing the long-held dream of practical supersonic passenger travel. By addressing the fundamental challenge of the sonic boom, this initiative could unlock new possibilities in aviation, potentially transforming the way we think about distance and travel in the 21st century. As we await the results of upcoming tests, one thing is clear. The quest for quieter supersonic flight is pushing the boundaries of aerospace engineering and bringing us closer to a future where the skies are not just the limit, but a gateway to unprecedented global connectivity.